All right, welcome back to our third lesson in this unit on sample spaces. So up until this point, we worked theoretically with calculating probabilities based off of our past understanding of the topic. But um, that kind of only is efficient when we have events that we are familiar with, or events where we have some type of constraints, like we know that there's 20 numbers in the bag, or we're working with words. But probability obviously is a very complex theoretical topic, and we can definitely find ourselves in very foreign, strange, and complex events where our intuition may not be, hardwired to the point where we can compute all these probabilities effectively. So being able to define the sample space is very important. We're learning to create in writing and using other representations and coordinate orally in writing different representations for recording sample space for trans experiments, so I can use organized lists, tables, and tree diagrams to calculate properties for compound events. I'll know I've got it when I can create organized lists, tables, and tree diagrams and use them to calculate probabilities. All right, so our first activity is maybe a bit engaging. There's a manipulative. So a standard number cube is a cube with each side labeled with one of the numbers 1 through 6. When rolling two standard number cubes, one of the possible outcomes is 1 and 1. Before you begin to roll the dice, make a prediction. How many possible outcomes are there for rolling two six-sided die? You might say 6. You'll submit that, and you'll explain your thinking. You might say 60. You'll submit that, explain your thinking. When you press to roll dice, every time you press the button, a new roll will be generated. Unfortunately, I was unable to create the dice that way they were spinning. Technology can only do so much. Okay, we got doubles. Some things you might want to consider. We have 1, 6 here, right? Player A is 1, player B is 6. If player A gets 6 and player B is 1, is that technically the same roll, or is that technically a different roll? So things to consider. The sample space of an event shows all of the possible outcomes. I created a table to represent the sample space of the dice. You can use the table to show all the possible outcomes, and then the interactive from the previous slide can assist you, right? So if I roll the dice, player A got 4, player B got 1, and I can come back here, and player A is A is it's the first one, and player B is the second dice, right? So 4, 1, right? And as you might be able to tell as you complete the table, this table represents the sample space. So does the table align with your prediction from before? So after having a little bit of fun, rolling some die, let's work our way into spinners. Spinners can get a bit confusing based on how many partitions they have. So each of the spinners is spun once, right? We have spinner AB, we have spinner LMN, we have spinner XWYZ. Diego decides to make a list of the possible outcomes, which can be very tedious. Lynn creates a tree diagram, as we see here, to keep a track of her outcomes. And Tyler decides to make a table. So in order to make a table, he needs to first make a table with the first two events before creating a table that includes the third event or the third spinner, but using the events generated from the previous two spinners. So using any one of the representations modeled here, Diego, Lynn, and Tyler, how many outcomes are in the sample space for this experiment? And now let's look at these in a more in-depth fashion. So one of the outcomes from Diego's list is BLX. Where does this show up in Tyler's method? Where is it in Lynn's method? BLX. All right, so you have to go back and you'll have to identify it and give a little justification as to where it is relative to Diego's list. And then I'm going to ask you to generate some initial probabilities that we'll probably talk about in class. When you spin all three spinners, what is the probability that they point to the letters A and Y? What is the probability that they point to the letters AMW, ANZ, or BNW? Okay, once again, we're still in the beginning of this unit, so things should feel very uncomfortable and very foreign. The only way that we'll actually get better at these things is by persevering and working our way through. So your final task will be to create your own sample spaces for each experiment. Okay, I've given you an opportunity to create a table. If you press enter, you'll have more rows, so on and so forth. If you decide to make a tree diagram, you can upload a photo of that here. I'm not in the student portal, I'm on the teacher side of things, but you'll be able to upload a photo for a tree diagram. And then if you want to make an organized list, you can simply type that into here. But for the first experiment, you have a standard number cube being rolled. So our standard number cube is numbers 1 through 6, and then a coin is flipped. So I did the coin flip possibilities for you. It's your turn if you decide to use a table to determine, how many events are there when you are rolling a cube, and vice versa here, right? We have a class block is chosen from block 1, 2, 3, 4, or 5, and then a subject is chosen from English or math. Right, so I've taken the liberty of the English math because that's kind of 50-50. But you need to determine how many events are there. It's kind of intuitive at this point for deciding between the class blocks. And last but not least, of course, I wanted to elevate your abilities, but we have 2 spinners being spun. I took the liberty of showing you that there are 4 different outcomes for our first spinner, RBWG. You need to determine how many outcomes there are for the second spinner, and then see what the sample space looks like, and that is how we'll be able to generate probabilities moving forward before hitting our lesson 3 summary that you can read through. It's a bit lengthy because they make sure that you see all the representations. Right, we have the list here, we have the table, and we have our tree diagram, and that's where we'll pause for today.